well, the linear regression that I talked about, you know, in fact, even the textbook that I was using gave very specific instructions on how to put that into your graphing calculator. Okay.
The HP, by the HP model.
Yeah, that is one. Yeah, right. I'm a Casio guy. Sorry, it's only in TI. Yes.
Well, I think that like on the previous one where it did have rational roots, and you could have done it with this, and it would have gotten out these nice rational roots.
Mm-hmm.
There's such a value of seeing it in different ways. I took a kinematics class where we did it by hand, and then we did it in a simulator, and then we actually saw the robot move, and with a piece of graph paper behind it to see if it showed up in the same place. And you could always tell which of you thinks was wrong, because two of them would agree. And it gives you such a value to be able to say, I see the graph, I can see the roots are here, I can do it by hand, and if one of them's not right, I can kind of fix it up again until it is right, and not spend all of my days playing this game of something is wrong someplace, figure it out by going through all the steps.
No, you're right. With the Newton part, that's unrelated to the graphing routine that I use. So this is just seeing it in two different ways right now, but
Right,
put
and
this
if you
in,
could
right?
do it, if this were a quadratic you could do by hand,
Mhm.
then you would also see three different ways of the same problem.
Yep.
And it adds a strange understanding to it.
Yeah.
In addition to the learners learning the Python, studying the Python, are these points of mathematics study as well? You can just look and think about these functions, these terms, and the entities they're manipulating. Do you have them spend that time?
If I can address that one of my favorite classes in the university was numerical methods, which is exactly that. I love numerical methods. It was like, how in the world can you do a sum and write some big table inside? Yeah.
Yeah.
Called numerical methods. It's really cool. Sorry.
Yeah, no.
And
Thank you.
at grade level that you're addressing the same sort of thing?
I
Or
think
is it
numerical
too
methods
early?
kind of in a college
I think it
level.
is.
Yeah. Yeah. But
Same thing, just more detail. Like,
Yeah.
Or just stop at a different previous English lesson.
yeah, that's right.
Number of those.
But at a certain level, I mean, at a certain grade, they stop using y is equal to something, and they all of a sudden start using f of x is equal to something. It confuses, well, the kids I see, you know, a lot, because y changed from y to f of x, but if you're using Python, okay, it's a really important thing to be able to think in terms of functions, and a function is a really useful tool. Like, it really doesn't do it justice. You know, it's so vital to be able to call something a function and then call it later on in another routine.
Is it too early for the grade levels you focus on to drill down, why does this work? And what is it doing to be able to work?
Right.
Is it too early in the grade level to explore such questions?
How does it work?
Right.
How
I
does
mean,
it generate the numbers and plots?
For the graph, here's the XY position. It's just calculating its position. Here, it's really long. It's like 10 lines. Put your pen up, set your color to black. The step size is going to be 1/100th of a unit. Set your position to way over at -3, and then whatever the function of -3 is. Then put your pen down. Yeah, I've forgotten that a few times. I've got the big streak across the screen. Oh. Set your heading to 0 in the turtle module. That's okay to the right. And then 500 times you want to just go forward to the right just a tiny bit, and then set your y value to the function of your new x coordinate. So it's really doing a zigzag. If it were a bigger step size, you could see that it's kind of zigzagging around the screen. If you make it a small enough step size, it's slower, but it looks like a nice curve. I think the fact that it's still called a turtle module and not something really scary, techy, mathy sounding makes it more accessible to, I was going to say kids, but God, you know, grown-ups who, I don't know how many scary haircuts I've had when the person says, well, what do you do for a living? I'm a math teacher. They're having a conniption while I'm sitting there. Put the scissors down. We're doing real math, techie stuff. So I've gotten up to Python. We've been doing, stuff with the pre-calculus or Algebra 2, and I've had enough experience with like homeschoolers or kids who are higher or lower in grade that you just find out where they can fit in, what they can do. Okay, you were showing Scratch. I mean, Scratch is golden. It's written in Logo. Derivatives are just slopes. If you've been doing slopes, you can do derivatives. So let's see. So I was thinking to myself, okay, great, we've got Python. What's something that I can experience, some real thing? I'm a mathy guy, and oh wow, look at that graph. And even my wife is like, oh, enough with the graph. Is there something real that, in science class, at one of the schools I was math/science teacher, and how about science and physics? What can we do using computers that we couldn't do any other way? One of the things that I've thought of for years was the orbit of planets. It really looks to me like the sun starts over there and moves over there. That's just me. Okay, but these astronomers say that we're orbiting this, and Copernicus said it was circles, and Kepler said it was ellipses, and Newton came up with a formula that closed the door and shut off the lights, and there's no more debate about it. Really? Does that really make elliptical orbits? So I thought about that for years. I tried to do it in Logo, and maybe I wasn't good enough, or Logo didn't have vector capabilities. I know it's got lists, but I didn't master the lists in it. I always went back to thinking about that. But it would be great to know, hey, all I did was code in this force and this velocity, and here's what I got. There's no getting around, learning that. How do you know that? Well, that's because I just did it. There was nothing else on the outside. Even me showing it, yeah, it could be messing with you. I didn't show you the real, For a student to do it is major. So somehow I stumbled across Visual Python, and that opened the door. Because I'm a math guy, I know my vectors, and in Visual Python everything is vectors. The position, the velocity, the force. All right, only those three things. But those three things are really important in these models. So the program does all the number crunching for you. Again, this is not something that really could be done by hand. And somebody saw the video and was like, oh yeah, that's Euler's method, where you don't know the position of something, but you know where it's going to be facing. So you put it there and you face it and you make it go forward a little bit. Now you recalculate. I could do that a couple of times, but your hand's going to get tired. So what better way than with a computer to do this? So at first I just thought of a projectile problem, just a simple, let's see. And no better way to start a program. Visual, visual. Because I was trying to import the visual or get the Visual Python on my Linux computer, and I was having all kinds of trouble. I'm not the best Linux, the most experienced Linux guy. And the guy who created Visual Python was very active in the forums, and have you tried this and tried that? So I quite agree that this is the kind of community I want to be in. And that's the thing, we're talking as parents and people who are interested in math, but I'd love to get in front of the group of teachers like this and say, here's what you can do, and I'm available to walk you through it. If you're going to do this with students, because we work with 100 students this year that I've been teaching through the Summit schools, 2 in San Jose and 2 in Redwood City. Okay, but if I could get a bunch of teachers, then it could be affecting a lot more students. And that's the only reason why this isn't better known is because they just don't know about this stuff. I didn't know about this stuff before. Yeah, the kids say, can I do my homework in Python? I didn't know. So let's see. For the projectile, what I love about Visual Python, because previously, in order to do any kind of graphics, you had to do pages and pages of C++, and it was ugly. I wouldn't. I'm sure it made me. I was stopped from learning all the languages like C++ when I just didn't know why I was doing half the stuff. But with this one, if you wait long enough, I guess, you'll get a nice sphere.
Need to move that VPython window.
Need to move it? There you
Yeah,
go.
right.
Just move it. Great. And it's interactive, in theory.
It's straight, you can tell.
Yeah.
Glitching a little bit, huh? Close down all
Oh.
my Python. No problem.
Well, it's starting back up. Have you ever experimented with PyPy to start these programs?
No.
PyPy makes things like that go really fast, but it doesn't work in all cases, so I was curious if you ever had a chance. It's a really way of taking a visual thing like that. Like
Okay.
I saw this video editing, it was like clip, clip, clip. I was like, you see this guy's being done now.
It's a
Okay.
sneak peek.
But you might come up with things.
Thank you.
What's it called?
PyPy.
PY.
Yeah, that's right, technically.
That's the just-in-time
Nope, still gonna be-
compilation.
This is
Just
just
the-
that.
this
the whole
sub-process?
piece and all the
Just
page
move it, it
right
blocks it.
Ah.
If you move it, it blocks it.
there.
Let's see, how about
It's
just
it's a refresh problem.
VPython?
But, you know. So it starts up and you have to
Move the window.
Move the window
Move the
in order to
switch,
make it
yeah.
go.
Mhm.
Yeah.
All right.
Ah,
And it provides a light source? The hanging provides a light source?
All right, let's see. So we'll make our ball a sphere. And here's where we give it a, this would just be a projectile. So its position is a vector. We'll put it at 0, 100 meters up. And otherwise it defaults to 0, 0. Radius is 3. What's your favorite color?
Red.
Red. That is red, and most important thing for us visual people, make the trail, make it leave a trail.
Capital T, I think.
Capital true?
I think it's,
Capital T.
you sure?
Yeah.
In Python, yeah, but
Yeah.
if I'm wrong, I'll
Sure.
beg forgiveness. Okay,
Here, move that VPython window. Oh.
okay. Pie, you say, huh?
We'll do it now, it takes a while to set up an experiment.
Yeah, we set up
VPython.
next.
so VPython is a whole another Python implementation?
It's
Oh,
a big
yeah.
library.
Okay.
So you
All right,
have
so
to
there's
move the
a-
window to make it run, or, no, there it is.
There it is.
There it is, yeah. So we have it, it's 100 meters up. You haven't got it doing anything yet, but, right, we can zoom in and zoom out on it. Okay. Working. And we'll give it a velocity. This is going to be a vector. In the x direction, let's see. Nothing in the x direction, we're just going to make it drop. Actually, no initial velocity. Why don't we just, and then the force of gravity to be a vector, of course. Nothing in the x direction, and then negative 9.8 y direction. Nothing in the z direction. We'll do this 50 times or so. Let's see, we'll make the ball's velocity has to update itself according to the gravity, right? And then the ball's position updates itself, and here's the shorthand for that, according to the velocity. All right. Let's see. We'll say if it crashes into the, no, let's see. We'll just keep it going.
Yeah, collision detection.
If the y value is less than or equal to 0, just brake.
Can we make it not red after all because it's against a black background?
Sure.
By yellow.
Yellow, that's a good choice.
Good song. Okay, that was fast. So what I'm showing you, right, the bare bones, make a sphere, get this to do this, and we can tweak it however we want, because we want to be able to see what it does. So found out that making the rate in the turtle module at speed, but that'll slow it down. Mhm. So it gets to the bottom and stops. If, let's see, we wanted it to bounce,
Negative. Subtract.
subtract what?
Go back up and see if you hit the top.
Change the velocity.
Right.
Plus minus.
Plus minus,
Ball dot plus minus ball B.
make the velocity
Y. Yeah, just Y.
equal to, right, -1 times ball velocity.
Then the top. You need to check the top. If you hit the ceiling.
No, I don't think it's going back up to the ceiling. We can figure that out by, let's see, giving it a little bit of x direction.
Okay.
Then what kind of, let's see. Oh yeah, then it just goes to the negative of that. Let's see. If we want to show this, let's see, we'll make the
Is
ball,
it moving in the z-axis?
the
Oh, just Y. Just Y. Yes.
Yep.
Just Y. Yeah.
Mhm. Hmm.
Oh, that's odd.
That's I thought it'd go back up.
So let's see, I think what it is the step size is too big, so if we, just like before, if we make the step size even just 0.1, then the force of gravity has to be changed, and let's see, then it's moving,
In position, you also need to multiply velocity.
Yeah, just use the dt, multiply velocity and
Mhm.
and ground, don't mess with.
that's right, well, yeah, the force of gravity is already multiplied by that, right? Okay. We make it go a little faster and a little, repeat it a little bit more. Okay, so we have a projectile and we have force of gravity. Okay, now a student who codes that for themselves and sees that is, when you talk about Galileo, when you talk about, acceleration, they're going to have the experience to understand that. It might be like, what, Galileo never did this? It would have been so simple for him to just show like I'm doing. So, I don't.
It could be misleading because it doesn't conserve energy, right? So there is numerical dissipation.
And these are the kinds of things that you can absolutely code in. elastic bounces or
Dampen.
damping. Okay, so obviously not everything's going to bounce like that. So you can obviously change the display. So, I guess the scene.
Once the students have this, they immediately want to make a Madden football game?
Why not?
Well, I
Make it
think
fun.
a lot of times they'll start making a game.
Yeah,
Yeah.
some game.
Like, can you
Pac-Man.
bounce, can you pick it so that it always hits this spot where they bounce?
Yeah, sure.
So they go off and they have fun for a while with their new shiny app toy. That's okay.
Probably with more realistic physics.
Height is 600, you just make it bigger.
What grade level is experiencing this, Peter, in your school?
Let's see, I haven't done the visual with the high school classes yet, but I've done this with he's a junior or senior, the homeschooler that I work with. So the display, you can make it larger, and as you can, it's got a little title on the top there, projectile motion. So you came here tonight to see the orbits, though, which we can use from this. You can just change this around to be a projectile. Let's see. So it's not going to be a ball, but let's see, we'll make the Earth a sphere, making it on the x-axis. Let's see. Negative 200, and the radius is still 3. Color. Actually, this is pretty cool. With Earth, only Visual Python does this. Let's see, material. And I may have left out an S there. Okay. That's the Earth. Suppose you want a sun. We'll leave that in the middle, so we don't need to say what its position is, but we'll give it a big radius. And its color. When it's big enough, we'll be able to see it. So let's see. Now let's see, Earth. Earth's velocity, we'll give that a vector in the y direction. Actually, call this t to 0. And of course, for the force of gravity, according to Newton, the force of gravity is just the magnitude of the, let's see, unit radial vector. So we need one of them. And that's just going to be the position of the sun minus the position of the Earth. That's the radial vector. Let's see. Unit has to be divided by the distance. So I guess we have to. So the distance, square root of, let me see, it is the Earth. Since the sun is at the center, this is easy. Earth's x coordinate squared plus the Earth's y coordinate squared plus the Earth z coordinate squared. Suppose the computer will want to know what a square root is. Math. All right. So, force of gravity is just what? That little tiny number times the mass of the sun times the mass of the Earth divided by the distance squared And that whole thing is multiplied by the unit radial vector. Oh. Times, let's see, and that's going to be going towards the sun. So let's see, all of these are constants. G, big M, and little m are just constants. And I did code in, went on Wikipedia and found out all the masses and the radii and all that, but it doesn't work out very, very well. So we're just going to come up with a number for those. Let's see. And all of this has to go inside the loop. The force of gravity. Earth's velocity has to be updated by the force of gravity in the Earth's position by the Earth's velocity.
We're becoming differential equations then?
Actually, I like to think of this as avoiding differential equations. Yeah, you're using vectors. There are ugly, ugly differential equations that if you want to find out where it is at t is equal to a certain time, okay, feel free. But with these vectors, which really is Euler's method, right? You go a little bit, turn, go a little bit, turn. Okay, that is what you're doing, is solving differential equations. We can print out t and find out where it's going to be, stop at t is such and so. Yeah, we can do that. If the Earth, no, if the distance is less than or equal to the sun's radius, then stop, go back. Less than or, yep. Okay. I feel like one of the summit students. Oh, Mr. Farrell. Oh, did I leave something in?
You don't have
That is
to
like
break right there.
Okay. Oh yeah, no, I want to say this is the Python. I knew I left out an S. Materials? Because that's the cool part. It's not just a green sphere. So you can, oh yeah, it only,
Inconvenient when that happens.
let's see. Where is it? It's here somewhere.
Well, it may be on escape velocity, actually.
We just need to,
If you set the velocity a little lower, we can crash it into the sun instead. Piece of software. That will move those.
get around the whole.
So here's what's happening. Here's an orbit. So when you set it,
All right, good old ellipse, just like Kepler said. Let's see. Oh, here it comes. Still. It's leaving a trail of pollution behind it.
Just like the real Earth.
There, it's still going. So yeah, I was impressed at the Earth has got the material of the actual Earth there. Where are you? There you are.
Oh, nice, nice. It's the real Earth.
Wave.
Oh, it's the Middle East.
Google Earth in real time. It should be, huh?
Can I see my house?
It's on fire.
Source of the light from the left.
Bouncing off the moon.
And that's a good point. I haven't even scratched the surface of what, you know, visual Python can do as far as changing the perspective and changing the light source and stuff like that. It's just so rich for, and I mean, this didn't take a whole lot of, you know, coding. Actually, when my wife saw the video, she said, that is a lot of code. No, it's really not. In order to get students to play around with ideas in physics and astronomy or gravity, you know, even history. Yeah, what was the big problem? Why was Galileo put in, you know, house arrest? I mean, these kind of things have some bearing on, you know, education, and I like getting the historical perspective of it, and I like getting the math perspective, the science perspective, and I mean, you're using Python. What could be better? I mean, if all this stuff, like you were saying, well, what if they just say we want to play with this? Play. Go ahead and play. Get used to using variables and loops and conditionals, and okay, you're going to come out of it with a pretty good grasp of computer programming. Okay, so that's my one trick for tonight. I thank you for listening to my story leading up to this, but I'm honored to come in and share with you guys. I'd love to share with teachers and other parents and techies, and I do appreciate the context or the, how about this, how about that? That would be, I'm writing that down, and I'll claim it as my own idea in my next, you know, then I was thinking, why not put in a light source? So if you have any questions, I hope I could answer them, yeah.
Have you been approached by the Khan Academy yet?
No.
Have you heard of them?
Oh, sure.
Okay.
Yep. I love Vi Hart's videos. So people ask me why I don't put any narration on the videos. First of all, it's to make the students actually watch the video. My voice puts them to sleep, or maybe it's just grown-ups or